Good afternoon, one and all. This is the 12th session. Today is 7th of May. We are going to see the 12th lecture in control system. Now, last day we had seen one numerical. We had solved it by two types, and in that, one type of solution was having shifting the takeoff point after a gain block, and there was another type in that numerical. What we had found was we had to take the gain block after the summing point. That was the first step, and second point was swapping two summing points. So it was not shown very clearly in that numerical. So that numerical you will find in the book of M. Gopal, page number 110, 111. So that numerical we will see today. I have handwritten it. Though the notes I have uploaded, but there this intermediate steps are not shown in detail. So the lecture 11 has been uploaded in your Google Classroom. You can check that. But in today's session, what we have planned is we are going to do some 4 to 5 numericals, and all these are typical examples. So we will mainly see the shifting of takeoff points before and after the gain block. We will see swapping a gain block with a summing point, and finally we will see how to swap two summing points. So all the numerical that will be done in today's lecture will be very typical, and I think this will be the last session on block reduction technique. So next week on Monday, we will start with the second part, that is the signal flow graph. So a lot of numericals I have solved. So most highest difficulty level numerical I'm going to show today, and whatever numericals I have solved. Okay, so those numericals will be uploaded in by today or tomorrow, and that will be a PDF, that will be handwritten material. So please prepare that, and definitely one separate session will be there on block reduction technique numerical, signal flow graph numerical, stability analysis numerical. All the sessions will be conducted in next week in the Saturday by 3 to 5. And tomorrow is Saturday. Tomorrow also we are having a session from 3 to 5 in the afternoon, and there we will discuss about the numericals from module number 1, that is a mechanical translational system, mechanical rotational system, electrical system transfer function finding, and all those difficult things we will be solving tomorrow. So this is the module topics that is there. So this is the first numerical that we are going to do today. So this numerical you will be finding all the difficult processes that are there. That is shift of one point before and after, and swapping the summing points. All those things are there. So if you see this whole block diagram, there are mainly 2-3 problems. So this G2H2 is not a problem. This is G4 and H2, not G2H2. This is G4 and H2. So there is a clear-cut loop. There is no problem in that. But you are finding that this loop H1. Okay, so this loop H1 and unity feedback path. Unity feedback path is also a feedback that is actually having feedback gain of 1 with negative feedback, and this is feedback gain of H1 with negative feedback. So both these loops are entangled. Entangled means if you want to solve this closed loop system with unity feedback, you cannot do that because it is entangled with H1 feedback loop. Okay, but we are finding is SP1 and SP2, they are side by side. Side by side means one thing comes after another. There is no gain block in between SP1 and SP2. So this is the ideal scenario that we can swap the position of SP1 and SP2 with whatever signal they are containing. That means this SP1 will come in the right side with this feedback of H1. SP2 will go in the left side with the feedback gain of 1. So that we will see. So that is one thing we are finding problem. Second problem is you will find that whatever this takeoff point is there, which is starting between G2 and G3, this is actually creating a problem. So in this circuit mainly there are two problems. First is SP1, SP2, they are entangled. So we can swap it very easily. So SP2 we can take left, SP1 we can take right. Okay, so this numerical you prepare very properly because all the things are explained in this. And second thing is we can take this takeoff point after something and we can take this ekdam close to this CS. So these two are the main jobs that we will be doing. Lastly, this unity feedback path we will take. So what all steps explained in this? So there are mainly two steps. First is take the unity feedback path which is ending to SP2. Okay, so all feedbacks are negative in this system. So take this unity feedback path towards the top. So how to do that we will see in the next slide. And that is the first thing. And second thing is swap the point sp1 and sp2. So that is written here, interchange the position of sp1 and sp2. So we call it swap or interchange, same thing. Now this is the figure given, so we will see the solution, what how to proceed for it. So again I'm telling you there are mainly 2 points, 2 problems, that is sp1 and sp2. Just check that they're overlapping kind of a thing. Okay, so we have to separate it out. So for that we can exchange the position of sp1 and sp2, so that problem is solved. Second problem is this h1 is connected between g2 and g3. Okay, you can take it left, but then also it is not going to solve your problem. Okay, one mistake I'm finding here, there is mistake from my side, that G1, G2, G3, all these arrows should be rightward. So whenever you're doing in the exam, so all rightward arrows you should mention. I have drawn the connecting lines, but I have not shown the arrow. That's a mistake on my part. You please correct it. All the arrows should be to the rightward side. Now we are finding what is the solution. So whatever path was there, so first is I have exchanged sp1 and sp2. So sp1 was left, sp2 was right. Now in this diagram, sp2 have been taken left and sp1 have been taken right. So what was the connectivity with sp1? With sp1 connection was h1. You can find that from g2 and g3 it was coming in between g2 and g3, and it is generated, and through h1 it is coming to sp1. So it is generated between g2 and g3, and then through h1 it is coming to sp1. So this is the first thing what we are saying. Second thing, it is this negative feedback path or unity feedback path. That unity feedback means h is equal to 1 feedback gain. So that is starting from cs and it is coming to sp2. Okay, so here also you are finding, but that we are showing above. So this point we have taken above. So cs it is getting generated, it is coming back, and it is coming back to the sp2. So while swapping the summing points, you have to remember one thing, that whatever things are connected with that summing point, that should not change. Only the position of summing point should change. So here through sp1 h1 was connected, so sp1 h1 is connected. Feedback was negative here, feedback is negative here. That is not going to change. From output sp2 there was a unity feedback path. So from output to sp2 there is a unity feedback path. That path is also same, and this is a negative feedback. So all these things are same. Now what we can do is, now we can solve this G4H2. And if you're solving it, it is a negative feedback. So G4 divided by 1 plus G4H2. This is what is becoming. So G4 divided by 1 plus G4H2. Now this G3 is there. So G3 and G4 by 1 plus G4H2, they become a cascade. So you can very easily multiply that. So what this thing becomes is G3 G4 divided by 1 plus G4H2. Now the whole thing you can represent as a Gx. Okay, so you can write in your exam paper also that G3 G4 by 1 plus G4H2 I am representing as Gx. And in the final transfer function, when you find, there you have to substitute Gx with G3 G4 by 1 plus G4H2. Otherwise, every time you have to keep on writing G3 G4 by 1 plus G4H2, and that might give you some error. So this is one of the trick I'm telling you, that is after you are solving this easiest loop. So this is the first loop we can solve. This is the easiest loop, clear cut loop. There is no entanglement. So after we are solving G4 by 1 plus G4H2, and then we are finding that G3 is coming in cascade with that, then G3 G4 by 1 plus G4H2 you can represent as Gx, and that thing you can carry forward as Gx only. Okay, so from here to here, this is the first step, and this is the most critical step. Once you do that, now things are easy. Now what is the problem? The problem is again the same diagram I'm showing here. Now next step is I will shift this point, whatever is point here, that is h1. So between g2 and g3, this point. So this point is not allowing me to solve this loop 2, which is above. What I'll do is I'll take this h1 point, so this takeoff point I'll shift after this g4 by 1 plus g4 h2 block. So you have to understand what is the entanglement, what is the problem that you have to understand, that this point between G2 and G3, this point is not allowing me to solve for the loop above, that is G3 feedback loop. So how can I solve it? What I have to do is I have to remove this entanglement. I have to remove this entanglement by shifting this takeoff point after the G4 by 1 plus G4H2 block. So this is what is being done. So this is the point A, which is the pressure point now, which is the problematic point now. What I have to do is to remove the entanglement of feedback path H1. So feedback path is named by their feedback gain. So H1 is a feedback gain. So this entanglement has to be removed. Okay, so shift the point A to the extreme right, ekdam close to the CS point. So that is what I'm doing, and I have redrawn the diagram. So sp2 is first, sp1 is next, and g1 is here. After g1 it is sp4, and then g2, then g3, then h3. All the things are there, and this a point has been shifted after g4 by 1 plus g4 h2 block. So if you are doing it, whatever is the gain, after which you are shifting it. So what is the gain in this path? In this path, gain is g3 g4 divided by 1 plus g4 h2. So this is a very unique numerical. Please solve this thing very properly. So this point is being shifted after the gain of g3 g4 divided by 1 plus g4 h2. So this h1 has to be divided by g3 g4 divided by 1 plus g4 h2. So this is the third very big thing that you have to do in this numerical. So what was the first big thing? We had taken the unity feedback thing at the top. So this is the first big thing. Second big thing was we had swapped the SP1 and SP2. So that swapping is done. Okay, it is done here. So entanglement is gone. Third thing is we have to shift this A point to the extreme right. And what is the gain in between? It is G3 G4 divided by 1 plus G4 H2. I told you that you can write a big gain Gx for that. So in that case, it will be H1 divided by Gx. And how much is Gx? Gx is G3 G4 divided by 1 plus G4 H2. Now when it has come in this kind of a thing, now see that everything is very easy. Now there are mainly three loops. This is the first loop, loop 1. Okay, so what is the forward gain? Forward gain is G2, G3, G4 divided by 1 plus G4 H2. Again, I'm saying sorry because this is the main path, central path. Here, every arrow should be rightward. So please don't make mistake as I have done. So all the central paths should be having gain rightward, so that you have to draw. So now first solve this loop 1. Okay, so now everything is very easy. So loop 1 is G2, G3, G4 divided by 1 plus G4 H2 forward gain, and H3 is a negative feedback gain. And this is the first loop. So after you solve this, then you have to solve this below loop 2. Okay, because in that case, once this thing whole thing is converted into one G, okay, then you can solve it by this. So whatever G you find here, this G1 will get multiplied with that. Okay, and then this H1 by G3 G4 by 1 plus G4 H2 is the feedback factor. This whole thing I asked you to show as Gx, or you can show it as Hx also, because this is feedback. That's why you can show it as Hx. Okay, so that is another thing. And after solving this loop 2, you have to solve loop 3. So bringing the whole circuit at this point, this is the main challenging job. So what we are doing now is you can find out. So loop 1 we are solving. So this is the loop 1. Loop 1 we are solving. So G2, G3, G4 divided by 1 plus G4 H2. So if you multiply all this, this is going to give you a forward transfer function of G2, G3, G4 divided by 1 plus G4 H2, and feedback is H3. So G by 1 plus GH, because this feedback is negative. So now G is G2, G3, G4 by 1 plus G4 H2 divided by 1 plus this thing. Okay, if you solve it, it comes to be G2, G3, G4 divided by 1 plus G4 H2 plus G2, G3, G4 H3. So in this circuit, actually, there are 4 loops. One loop is already solved, that is G4 H2. Second loop, you are solving it. This one, we are calling it as loop 1 now. Okay, and both loops are negative, and all these loops are for feedback, negative feedback. Hence, in denominator, all the signs will be positive. So I think this is understood. So G2, G3, G4 divided by 1 plus G4 H2 divided by, feedback with H3. So if you solve it, it comes like this. So both the terms are positive. That means those feedbacks are negative feedback. So this is the understanding thing. So this is the first thing we have solved. After solving it, we are finding that this whole thing, loop 1, is looking as G2, G3, G4 divided by 1 plus G4 H2 plus G2, G3, G4 H3. So that again, while you are solving loop 2, okay, so this part is getting multiplied with G1. Hence the numerical comes to be G1, G2, G3, G4 divided by this denominator. Okay, and that is being fed back with H1 divided by G3, G4 by 1 plus G4 H2. So first, this whole thing is G2, G3, G4 into G1 divided by whatever is written here. So that is the numerator divided by 1 plus. Why 1 plus? Because it's a negative feedback. So 1 plus this whole thing, okay, multiplied by this feedback gain. So what is feedback gain? H1 by G3, G4, and whatever is written here, that will go again getting multiplied with H1. So it is H1 into 1 plus G4, H2 divided by G3, G4. So if you're doing that, the G3, G4 part is getting cancelled, and numerator and denominator both are having same denominator, that is 1 plus g4h2 plus g2 g3 g4h3, so they get cancelled. So now you take this part at the numerator, so numerator will be 1 plus g4h2 g2 g3 g4h3, this part, plus g2 g1 into h1 plus g2 g1 into h1 g4 h2. So if you're multiplying these two terms, you are getting two terms. Okay, multiply with this, so there will be two terms, and here you are having three terms. So this 3 will go here with 1, and here you are going to get as two terms. So 3 plus 2, there will be total 5 terms. So this g1 g2 g3 g4 is here, then 1 plus g4h2 plus g2 g3 g4h3 is there, so this thing goes up. Okay, and then this numerator. So what is this numerator? g2 g1 into h1 multiplied by 1 plus g4h2. So if you multiply that, you are going to get this. So this is the transfer function. This is the transfer function after we are solving loop 1 and loop 2. Now this whole transfer function will be having a unity feedback. What is meant by unity feedback? So it is g divided by 1 plus gh. Okay, 1 plus because it is also negative feedback. So this unity feedback is negative. So g divided by 1 plus gh, and h is equal to 1. That means it will be g divided by 1 plus g. Okay, so as h is equal to 1, because this is unity feedback, so net final transfer function will be cs by rs is equal to g divided by 1 plus g, and where g is the whole thing. That means with this denominator, one term will get multiplied, added. What is that term? This is nothing but g1, g2, g3, g4. So if you're doing this, so if this is g divided by 1 plus the same term, then what we are going to get is, so check, you are going to get the same thing, g1, g2, g3, g4, it is there. So g1, g2, g3, g4, it is there. And whatever is the denominator here, with this denominator, one term of g1 g2 g3 g4 will get added. So how many terms will be there? This 5 plus this 1. So this practice also you have to do. Some of you people are not able to add and subtract this ratio forms and all, so please practice. This slides will be given to you, so please practice this numerical. So this is g by 1 plus g, because h is equal to 1, then g means this, and 1 plus g means 1 plus this, again numerator will get cancelled. So with this 5 terms will get added, g1 g2 g3 g4. So this is the term which is got added with the previous term. So if you're leaving it here, cs by rs, this is also correct. There are 6 terms we are finding, 1 2 3 4 5 6. Okay, this is a new term which has happened because of the unity feedback. And now if you want, if you you can write in this factorized form, but not required. Okay, so if you're leaving it here, it's okay. And sequentially one term, your term, my term can be आगे पीछे हो सकता है, but the terms should be same. Okay, so you might be writing h1 g2 g1 first, or g4 h2 at the last, that doesn't matter. Okay, so all the 6 terms we check categorically, and if you are finding that all 6 terms at the numerator denominator is correct with your solution and my solution, this numerator term is correct between your solution and my solution, as soon as I find that, I give you 10 marks. Okay, and if there is little mismatch, then we go backward and we check. Okay, and some kind of part marking is done. So at that time we will check, okay, up to second loop whether it is correct or not. So up to which loop you have made it correct, that we check. But yes, if you are making mistake here, while finding, shifting this point here and other thing, ekdam starting mein, if you make a mistake, then you might get 2 to 3 marks. Okay, so be very careful, do this numericals properly, and it requires some practice. Thing is easy, thing is very easy, you will find, but this requires some kind of practice. So this was the first numerical that we have done. Second numerical, so in yesterday's lecture I helped you with a numerical which I said we all examiners like that kind of numerical. Okay, so we will do those numericals now. So 3 4 numericals we will do now, and in that we are going to do this is the first numerical, this we will do. So I will share my screen. It is my handwritten notes, so please just give me some time. Okay, I think it is very much visible to you. So whatever I'm showing, it is visible, but I'll make it a little bigger. Okay, I think the screen is visible. Any of you please say yes. Either you write in your chat box or you just say yes. Okay, so it is visible. So this is the first CS by RS numerical, and I'll make it further big because I want you to have a very good look at the system. Okay, so this is the system, and yesterday I had shown you, but that was my handwritten note again, but that was already converted to PDF. So today I've solved this numerical again in one page. So this is a very important numerical, and try to understand every part of it. Why this numerical is important is because it's having a summing point at, so there are three summing points. There's a summing point in forward path, so this is called as forward path, and this G2 and G3 you will find you can just add it and multiply with G1. So this forward path is very easy. Okay, so in this numerical, all the criticality is there in the feedback path. Okay, so you can find that there's a feedback path getting multiplied with H1. And now there are two components in the feedback path. So one is forward path and coming and getting added to feedback path. So this is very dangerous. Okay, because this G4 is coming. Now let us just find out what exactly it is. So this H1 is coming. This is the actually main feedback path. H1 is coming and this is positive sign. These signs are very important. So H1 is coming, and so this H1 coming positive means this is plus H1 and again getting multiplied with H2, and this is negative. So what actually is there? There are actually two paths. One path is, so this is the main feedback path, and this is having gain of H1 into H2, and it is going to be a negative feedback. Okay, whereas this path, so this path is feedback path H1 and plus, that means plus H1 and multiplied with H2 and going to the negative. So this is actually the main feedback path, and this is the only feedback path present in this system. This thing G4 is not a feedback path, it's a feed forward path. We will see what is that. So only one feedback path, H1 multiplied by plus multiplied by H2. So this is H1 H2 given to negative feedback. What is the second path? Second path is from here is coming G4 and minus. That means this is minus G4. And again this is getting multiplied with H2 and going to minus. So there are two minus. G4 is minus and then H2 again is minus. So it is actually minus H2 minus G4. That means it is actually becoming G4 H2, a forward path gain. Again I'll repeat, this thing is coming from here, this thing is going in the forward direction, so there's a forward path FF1. So what I have said is FF means forward path, okay, and FB means feedback path. So FB stands for feedback and FF stands for feed forward. So this G4H2 is a feed forward path, and how much is the gain? So you're finding G4 here minus, that means minus G4 into H2 into minus, that means minus of minus G4H2, that means plus of G4H2. So this is the feed forward path FF1 and this one is the feedback path. So actually H2 is common to this feedback path as well as feedback path, hence that has clubbed. Okay. So step what we are going to find is next step, separate out. So this is FF1 is feed forward path, F2 is feedback path, H2 is again block which is common for both this feed forward and feedback. What is the next step we have been doing is we will be separate out. Separate out FP1, FF1. This is the thing. So now SP2 is removed and FF1 and FB1 are separated. So if you are separating it out, what you are finding is from R coming a path with G4H2. So from R is coming a path with G4 and minus H2 and given to minus. Or you can say as G4H2 given to plus. Okay, this is the first thing. Why have I kept this minus? Because this minus sign is then common for feedback path 1 and feed forward path 1. That's what I have given as minus. Okay, so this G4 and minus H2. Why minus H2? Because this is a minus sign. So either you can call it minus G4 into H2 or you can call G4 into minus H2, anything you can call. But net effect of the feed forward path is positive. So G4 minus H2 is given to minus. So you could write that G4 into H2 given to plus. That is the first thing, feed forward. Second thing is feedback. H1 is coming and this is positive because H is positive. H2 is also positive. H2 there is no sign and given to negative. So plus H1, H2 given to negative. So if you are solving it, this right side image is very important. What you are writing is this is minus G4H2 given to negative. So minus G4H2 given to negative, and here on the top I told you that this G1, G2, G3 is very easy. G1, G2, G3 is not creating any problem. This G2, G3 both are additive form, so they are parallel gains, so it becomes G2 plus G3 multiplied with G1. So you're finding that in the forward path, it is G1 into G2 plus G3. So here also in the forward path, G1 into G2 plus G3. Feedback path, it is H1, H2 and negative feedback. So feedback path, it is H1, H2 and negative feedback. Now what you are finding is this path, whole path. So there are two parallel paths in the feed forward direction. So it is 1. So nothing is given here after R. That means this path is having gain of 1. So this is 1 and this path is having positive feedback of G4H2. So I have added them. This is a very important thing. That is, this forward path is having gain of minus H2 into minus, that is G4H2. So this is 1, this path is 1 just after R, and this path is G4H2. So I'm making it 1 plus G4H2 like that. And what is remaining is G1 into G2 plus G3, and there is H1, H2, which is in a negative feedback. So if you're solving it now, G by 1 plus GH, 1 plus GH, because this path is negative. Okay, so what it'll become G1 into G2 plus G3 divided by 1 plus G1 into G2 plus G3 multiplied by H1, H2. So this is that. So this is the second part and this is the first part. So first part is the feed forward path. You can find it here. That is, first part is the feed forward path and second part is the feedback path. Feed forward path is actually positive because all the negative becoming positive, and feedback path is actually a negative feedback. As feedback path is negative feedback, you are finding here is G1 into G2 plus G3 divided by 1 plus G1 into G2 plus G3 into feedback element, that is H1, H2. And first part feed forward, it is 1 plus G4H2. So multiply these two things now. What you are finding is CS by RS is 1 plus G4H2. This is the feed forward path multiplied by all the feedback path closed loop transfer function. That is G1 G2 plus G1 G3 divided by 1 plus G1 H1 H2. So G1 H1 H2 multiplied by G2 plus G3. So there is a numerical. You please understand it very perfectly, and you can practice it time to time. So this is mainly important. I'm giving you all the numericals, and you have to practice it time to time. So this is actually the numerical number 1 that we have done. So actually this is the second numerical that we have solved today. Now let us see another numerical where the same thing we are doing in a different way. So this is actually what we had done yesterday. So yesterday we had done this numerical, we had shifted this point after G4 and we called this H2 as H2 by G4. So if you see this, the whole numerical, what you are finding is there are three summing points, SP1, SP2 and SP3. So observations, first you have to understand what are the observations. So observation is SP1, SP2, SP3. First observation, SP2 is negative feedback, SP1 is negative feedback, but SP3 is positive feedback. Okay, so there is one positive feedback. That means once in the whole numerical there will come G by 1 minus GH. So one term in the denominator will be negative. Okay, that you understand from the beginning. Whenever there is some term which is a positive, you have to be careful because that's trouble. Because we are habituated in writing loop equation as G by 1 plus GH. Because 90% of the feedbacks in the whole control system is negative feedback. Most of the feedbacks are negative only. So we are habituated in writing 1 by 1 plus GH. But as it is positive feedback, we have to write G minus GH. Not write because we cannot make it a loop because H2 is a problem. Okay, because this H2 is starting between G3 and G4. So actually is we can shift this summing point. So one way of doing it is take this point after G4, make this as H2 by G4 and keep on solving it. So as soon as you're shifting it after this, all the three loops are open, they are not entangled, you can proceed it. So that is one way that I had shown you yesterday. The second way also was shown to you yesterday, but this intermediate steps were not done. So today I have done the intermediate steps and I will show you those two steps. One is taking the summing point to the left of G2. You can find here. So this is G2, SP3 is to the right. Now here what I have done is I have taken G2 to the right or SP to the left. So here you are finding that SP2 and SP3, they are consequent. So I am taking G2 to the right and SP through the left. So this is what I have done. So this step was not done in M Gopal and this step was not shown to you yesterday. This H2 is here. I'm not doing anything with the H2. Okay, so H2 is here. No change is made to this point. Okay, this point it is as it is. No change is made. I'm doing is I'm shifting this sp3 to the left and g2 to the right of sp3. This is the first thing I have done. And while doing that, what I'm finding is as you are shifting this sp3 to the left, what is happening is h1 is becoming h1 by g2. So this is a change which has happened. Okay, so take g2 to the right side of sp3, take g2 to the right side of sp3. Hence h1, which is connected to sp3, h1 will now become h1 by g2. So if you're shifting a summing point to the left of a gain block, in that case the feedback which is related to that summing point will be divided by this gain block. So these are things, as you keep on doing it, you will understand. So only one change first I have made is sp3 have been shifted to the left of g2, and it has been made, this h1 has been made h1 by g2. See that this point A is still there. I'm not shifting the point A. So that was the first thing. Now you're finding still it is still this, you cannot solve it, you cannot solve this loop because this is not a clear cut loop. Okay, because what you are finding is g2 and g3 is entangled. Okay, so g2 and g3 is entangled because if you want to solve this whole thing, g2 g3 has to multiply with g4, but it cannot happen because this sp3 is here, sp2 is here. So sp2 and sp3, they are still entangled. It's not a clear loop. Okay, you cannot solve it. So what to do that? Interchange or swap the positions of sp2 and sp3. In that, the gain between sp2 and sp3 should be 1. There should not be anything in between sp2 and sp3. That means the gain between, so it's just connection. Connection means gain 1. So in this case only, you can swap the position of sp2 and sp3. So just now in this lecture, the first numerical also we had done. There also we had swapped two summing points. So sp1 and sp2 are swapped. In this case, sp2 and sp3, they are swapped. Condition for swapping: whatever things are connected to whichever summing point, it will stay there only, to that summing point only. You have to change. So sp2 you are bringing right means this will be connected to sp2. No, that is not the case. Whatever inputs were connected to sp3 or whatever outputs were taken from sp3, that will go with sp3 only. Only thing is we can swap, or we can hardware wise we can just swap the position of sp3 and sp2. So you are finding that sp3 now comes to left and sp2 goes to right. So I have uploaded this numerical in a slide yesterday night for lecture 11. There I have given three colors. So I think sp1 I have given red color, sp2 I have given green color, sp3 I have given blue color. So after that step, where two steps was being done together, one was shifting of the summing point, and next was swapping of the summing point. So after that, what we found was this was red sp1, this was blue sp3, and this was green sp2. So now you will understand the whole numerical which is uploaded yesterday night. So same numerical I'm solving here only. Okay, so this is the third step. Interchange or swap the position of sp2 and sp3. So whatever sp3 was there, this is coming left, sp2 is coming right. Now you can find that this loop is now totally separate. Okay, so now this h2, so h2 has been creating trouble since the beginning. So now this h2 is free, and now we call this loop as loop 1. So g2 g3 h2, they form a negative feedback loop. What will be the transfer function? G2 G3 divided by 1 plus H2 G2 G3. So this will be the first loop, and then this is the second loop, H1 G2, whichever is related to SP3. So SP2 related components is the loop 1. So now I'm redefining the loops. So G2 G3. So after these two steps, you find that all entanglements are removed. Now you can go for solving the loops. So G2 G3 H2, they are forming a loop. G2 G3 by 1 plus G2 G3 H2 is the first, and whatever you are getting, that will be used the G in the second loop with feedback as H1 G2. So now you are finding the same thing. So here you are solving for this. It becomes G2 G3 divided by G2 G3 H2, and now this G4 is in with that. Solving the whole forward path can be solved with a feedback of H1 G2. You can find this H1 G2 coming to SP3. Okay, this SP3 is positive feedback, so this is trouble. Be careful. So this whole path is now looking like G2 G3 G4 divided by 1 plus G2 G3 H2, like this. G2 G3 G4 divided by 1 plus G2 G3 H2. It's very easy, repetitive kind of a thing. And now that is having a feedback of negative positive type and H1 by G2. And then there is the final or biggest feedback loop, that is from the output side to the input side with a feedback of H3 and negative type. So these three diagrams are very important. So first the main diagram is given. From there you have identified the problem, that is A is the problem. So either you can keep A as it is and do the shifting here. So what is the shifting? First you have shifted sp3 left, and then you have swapped sp3 and sp2. And after that you are finding all entanglements are gone. There you are solving for loop 1 first, then loop 2 second, and then loop 3 third. Okay, so after you have solved for loop 1, you are finding this. Now you will be solving loop 2. While solving loop 2, you are finding, so there is no more difficulty in that. So if you have solved for loop 2, okay, so loop 2 is given here, loop 2 is given here at the below. So again, if you are multiplying that, it will be G4 into G2 into G3, okay, like this. So that will come at the numerator. So G4 into G2 into G3, it is coming at the numerator, divided by this, and 1 plus this whole thing, whatever is there at the numerator, there is a thing, and H1 by G2. Why H1 by G2? Because you found that the feedback in the previous case was H1 by G2. So G by 1 minus GH, so two things are different. G by 1 minus GH, so that minus comes here. Okay, so G by 1 minus GH, so I'm sorry, this also should be minus. Okay, this thing also should be minus. Solution, be careful. So that's why G4 G3 H1, G4 G3 H1, that will be minus. Okay, so this should be minus, I'm sorry. So this is G4 G3 H1 is minus. Okay, and again you are finding like this, and again you are finding like this, and again solve it with H3, so that is not difficult. So now this is G, and G divided by 1, this should be plus. So I made a mistake, so this should be plus, the last one. So Y by R, this should be plus, and the top one should be minus. Okay, yes, plus mistake is something which keeps on happening, but it won't happen if you practice. But main thing is what is shown in the previous page. So previous page, how to remove the entanglement. So calculation is one part, and understanding and removing the entanglement is another part. So removing the entanglement is the first part, which is shown in the first three diagrams. So first, second, and third. Okay, so these three diagrams are removing the entanglement. So by the time you come to this third thing, now everything is very easy. So everywhere you have to do either by G by 1 plus GH, or you have to by G by 1 minus GH. So I will correct this too, and I will upload it. So below it should be 1 plus because it is at the negative feedback, and top in the loop 2 it should be 1 minus because it's a positive feedback loop. So this is one numerical which was solved yesterday by one specific method, and this is another method. So the same numerical, again you see, yes, same type of numerical. This is the next numerical, same type of numerical here. Okay, so what is the first job? We have to shift this. So this H1. So all the feedbacks are negative feedbacks here. What is the main trouble? Main trouble is H1. Okay, so if you shift H1 after G3, so in that case, this H1 will become H1 by G3 like this. Okay, so there's the first thing. If you shift this by after G3, now you can shift it after G3. So whenever you're taking this point after G3, then all these 3 points, so this is shifted after that. So this point shifted here, this point, and this point. All these 3 points are on the same point. Okay, so anything can be taken before, anything can be taken after. So that is not an issue. So only one thing I have to do here is H1 has to be taken after G3. That is the only thing we have to do. So if you're doing that, in that case, H1 becomes H1 by G3 like this, and after that it's very easy. So this is the first solution. This is the first solution, that is G2 G3 divided by 1 plus G2 G3 G4. You can find here G2 G3 divided by 1 plus G2 G3 G4 multiplied by G1. When this is solved, then there comes the second loop. Second loop is having feedback of H1 by G3. So there's a second feedback path, H1 by G3. Okay, so again it is minus. So everything is minus. And last is when you solve this. Okay, so G1 into G2 into G3 divided by 1 plus G2 G3 G4 divided by the whole thing divided by 1 plus the whole thing into H1 by G3. And after that, finally, what you are coming is you are coming to this one. Okay, so this is a second loop, and is a third loop. So after you're solving the second loop and third loop and all these things, so this becomes a third loop. So exactly this is the way you have to go in the exam. So loop by loop you have to solve, and loop by loop you have to keep on presenting. And everything is positive here, you can find. So everything is positive because all the feedbacks are negative feedback. So there is no positive feedback here. That's why everything becomes positive. for the denominator. So these were some of the numericals, especially that I wanted to do. Some more numericals we'll be doing now. I'm sorry for the mistakes here. These mistakes will remain in the video. I cannot change the video now, but yes, definitely we can change these mistakes in whatever notes I'm uploading. So this will be minus, and here this minus is there. So this G4 G3H1. So this G4 G3H1 part should be minus. And 1 plus G2 G3H2, 1 plus G2 G3H2 will remain here, not a problem. Okay. And here, so here it will be 1 plus G2 G3H2 minus G3 G4H1, it is there, and this should be plus. So in the right side I have made it correct, but while writing the formula I have made a mistake. So this thing will be plus. So I'm removing this thing now. Now I will go back to my specific node, and in that PDF which we'll upload shortly. So in that PDF we will see what all numericals we can do. Okay. So let me upload that PDF also. So many numericals we have done so far, almost 12 to 13 numericals we have done so far, and all are very chosen critical numericals. So some more critical numericals we'll be doing now. Just let me launch it. Okay, so we stopped here last day. Another 10-15 minutes time we are having. So 2 to 3 numericals we can do. So on screen, whatever you can find, that is actually the numerical just now what we have solved. So yesterday I stopped here and I told you that this is a numerical which is liked by all faculties, because here there is a forward path, here there is a feedback path, here there is a parallel path. So 3-4 different types of masala is there in this numerical. That's why we like it very much. And there is a summing point in the feedback path as well. Generally, we have summing point in the forward path, but in this we are having a summing point in the feedback path. So actually, there are two paths which are using common multiplier H2. Okay, hence summing point is there. So main job of summing point is it is reducing one gain block. Okay, that is H2 is used by forward path also, H2 is used by feedback path also. So we have clubbed this two, we have superimposed this feedback and forward path, and we are using only one gain block H2 for both the paths. Okay, that is forward path and feedback path. So that is the significance of this summing point. Otherwise, if you remove the summing point as we had done, here also it is shown, if you remove the summing point, then it becomes two separate paths and it looks like this. So this path is also having H2, this path is also having H2. So in VLSI, so I'm just deviating a little bit. In VLSI, whenever you will be designing circuits, you have to think of optimization of every block. Okay, so if there is one gain block, you have to see by how many times you can use the same gain block, maybe in the forward path, maybe in the feedback path, and you can reduce repetition of any amplifier or a delay or any block. You have to reduce that. So just remember this part. Okay, so you might not be able to understand fully, and in future when you will be doing some elective or something in VLSI, there you will see that optimization of gain block, optimization of circuit related blocks that you have to do. So whatever the system is there, initially actually the same gain block was being used, or which was common for both forward path and feedback path. We have removed that entanglement and we have separated it here, because in exam we have to solve it. So there you don't think of VLSI, what do we do? No, in exam we have to solve it separately, and first you have to separate the entanglement, and then we have to solve it separately and get the transfer function. So that's why this numerical was very, very important. Now this is another numerical. So all numericals that I have shown, VVI is written there, so don't worry. So here what we are finding is this path can be solved very easily. Okay, so there's another numerical you are finding there. This is the main body. Okay, this is the main G1, G2. This is the main path, main forward path. Where is the problem? So problem is this G1 is there. So first thing what we can do is we can solve this. Okay, so we have solved it and we have shifted this G1 after this summing point. Okay, this is what we have done. So we have solved it. As soon as we have solved, this below thing is gone. This H2 thing is gone because this is G2 by 1 plus G2 H2. So it has become like this. Again, I have missed some arrows here. So please connect all the arrows. So this is also a very good numerical. Okay, so first thing you solve this G2 by 1 plus G2 H2. This is what you are getting. And next step is, so it is not written, shift this G1 block after this summing point, or get this summing point before this G1. In that case, what you are finding is, as we did previously, if you are shifting a summing point before a gain block, then whatever is the gain related to that summing point, that gets divided by that gain block. I'll repeat, if you are shifting a summing point before a gain block, then whatever is the gain related to that summing point will be divided by the gain. So same thing you're doing here, you're shifting the summing point before the gain block G1. So now G1 has come here, there is no entanglement for G1, and whatever is the gain related to that summing point G3, it will get divided by G1. So this is what has happened now. So this is the first step, that is shifting a gain block after a summing point or shifting a summing point before a gain block. Now what you are finding? Now also you are finding that these two things are entangled. Okay, so this numerical at page number 12 is really very important because there are 2-3 twists. Generally we keep 1 or 2 twists in every numerical. If you can remove those twists, entanglements, then you are free. So first you have to go to that point. This is the diagram. So what we are finding is, now these two summing points, sp1 and sp2. So how many summing points are here actually in this diagram? 2 summing points only. So first we have solved this, and there is a summing point with 3 inputs. Okay, it is feedback is coming from forward G1 and it is coming from forward path gain G3. Okay, in the first path you have removed this entanglement. This is the first thing you have done. And next, whenever you are finding that these two summing points are side by side and they're entangled, you can swap them. Okay, so what you can do is, this summing point sp2 you can take first, and this summing point sp1 you can take next. So what you are finding is, this g3 g1 from rs is coming to the summing point 2. So this is actually summing point 2, which is shown first, and then afterwards this is summing point 1. So whichever was here, this summing point is going here. So this summing point 2 is coming first, and this summing point 1 is going next. Because this summing point 1 was connected to h1 with negative, here also you find summing point 1 is connected with h1 and negative, and then summing point 2 is connected to g3 by g4, g3 by g1. This summing point 2 is here, and this is connected to g3 by g1. Now everything is easy, because now initial part, what you are finding is, there are two paths. Okay, there are two paths you are finding here. It is 1 plus g3 g1. This whole path, it can be written as, they both are in right direction. So here also I missed that arrow. So all the forward paths are having a rightward arrow. So please connect that. So what you'll be finding is, this is 1 plus g3 by g1. This is the first path. Okay, it is here. And then finally, what you are finding is, this path, whatever is here, this is actually a negative feedback path. So if you solve it, it is g1 g2 divided by 1 plus g2 h2 plus g1 g2 and h1. So g1 g2 and h1. So the whole thing here is the answer. So this is a very simple small numerical, that is numerical number 14. Remember that, page number 12. Okay, so this is a very small numerical. Circuit becomes very simple, but for that you have to do this 2 steps. So what is the first step? First step is solve this. Second step, substitute G1 or take G1 after summing point. Third step is swap the SP1 and SP2. So these are the 3 steps. First is solve G2H2. Second is substitute, take the G1 block after the summing point, and third thing is SP1 and SP2. You swap that. If you do these 3 parts, it's easy. Otherwise तुम 4-5 पेज करते बैठोगे, आंसर नहीं आने वाला है. This is a 4-step numerical, and in half a page you can solve it. Just check. But for that you have to understand it. Now this is going to be the last numerical today. So we could do almost up to page number 13 and 14. We'll go ahead of it. So here, I know time is there, so just give me 2 minutes. What we can do is, first we will shift this point after G3. Okay, and this both are positive summing points. So you take this point after G3. So if you are taking it, G3, G5 becomes G5 by G3. Because now from here, if you are taking off, G3 is not multiplied with the signal. But if you are taking this point after this, that means signal is getting multiplied with G3 and then it is forwarded. But whenever the thing is being forwarded, G3 was actually not there. Hence, whatever is being forwarded is more by G times. So that's why you have to compensate that here. So G5 by G3 it becomes. Now, just by one shift, it is like here, you are finding this block. So what is this block? This is G4 plus G5 by G3. Okay, so this block becomes G4 plus G5 by G3, and this block is G2 G3 divided by 1 plus G2 G3 H1. So this is G2 G3 divided by 1 plus G2 G3 H1. It is like that, and now everything is very simple, and you just multiply all these 3 things, name it as G, GX, and then you can write it like this. So this is a very simple numerical, numerical number 15. Let me have a check. Those who want, those who are having jobs, you can just leave. Next day, whenever we are doing some critical numerical, we will start with numerical number 16. So this notes, whatever I have, I will upload it today itself. You start practicing. So this is another numerical 17. So first thing, you have to swap this. This is actually explained in your whatever slide I had prepared. There I have explained the 17 numerical. So this 16 numerical is very important. Whatever was given previously, please practice this. Okay. So this is page number 14, I guess. Page number 14, numerical number 16. My notes. Please prepare this. And the 17 numerical is already done in your class. So I have solved it in your class. So almost we have completed up to page number 17 of my notes. So last 6 pages, here also a lot of entanglement. You can solve it. So this is one, this is a big numerical actually. And there is something. So this is a numerical where there are 3-4 different inputs. Okay, question number 19, there are 3-4 different inputs. How to solve it? So almost this also I will explain it to you. So if there's a multi-input, multi-output system, how to solve it, and many other things are there. So I think 2-3 more numericals are there. This we will discuss in the special session because they are further more difficult numericals. So we will solve those in a very special session next week Saturday afternoon. Okay, so that's all from my side now. I will upload all the notes and everything, and I'll do that small correction in plus minus. That's all from my side now. Thank you. Good day. So tomorrow we'll meet again at 3 o'clock, 3 to 5. We will have a session tomorrow. That's all. Thank you.